You know, in programming, you're constantly juggling all sorts of information, right? You've got numbers, you've got text, you've got these true or false values. So the big question is, how in the world do you keep all of that organized in one convenient spot? Well, let's dive in and find out.
Think about it like this. Imagine you're packing a suitcase for a trip. You've got your clothes, a book, your phone charger. They're all totally different things, but you need to get them all into that one bag. We face the exact same problem in programming. So how do we build that digital suitcase? The answer in Python is something that is just incredibly versatile.
And here he is. Meet Leo the List. I want you to think of Leo as the ultimate magical backpack. Now, this definition tells us three really key things about him. First, he's ordered, which means he remembers the exact order you put things in. Super important. Second, he's mutable, which is just a fancy way of saying you can change what's inside him anytime you want. And finally, he can hold anything. Numbers, words, you name it. Leo can hold it.
Now, what's really cool is seeing how Leo stacks up against his cousin, the string. See, a string is kind of like a word that's been carved into stone. It's immutable. You can't change it, and it only holds characters. But Leo the List, he's more like a whiteboard. He's mutable, so you can erase things, add new things, and change stuff whenever you want. And that flexibility, well, that's his superpower.
So, how do we actually get things out of Leo's backpack? We use something called indexing. Every item has its own specific spot, or an index number. But here's the one thing you absolutely have to remember. In Python, we always start counting from 0. So the first item is at index 0, the second one is at index 1, and so on. That's why, to get green, we ask for whatever is in pocket number 1.
And here's where that mutability really shines. Let's say we're not feeling orange anymore. No problem. We just tell Leo, hey, index 3 should now hold black instead. And just like that, the original item is replaced and the list is changed for good. It is literally that easy.
Oh, and lists are social creatures. You can actually combine two of them just by using the plus sign. This is called concatenation. It's really just like taking everything from one list and just tacking it right onto the end of another one to create a brand new, longer list.
What if you need a bunch of copies of your list's contents? Easy. Just use the multiplication sign. Here, we're telling Python we want the stuff inside list 1 repeated 4 times. It's a super quick and easy way to duplicate your data.
Okay, now for one of Leo's coolest powers, slicing. Instead of just grabbing one item at a time, you can grab a whole section or a slice of the list. By saying 1:4, what we're really asking for is everything starting from index 1 up to, but not including, index 4. That's a key detail to remember.
So beyond those basic operations, Leo comes with this built-in toolkit of special functions we call methods. These are really powerful commands that let you manipulate the list in all sorts of sophisticated ways. We're not going to go through every single one, but let's check out a few of the most important tools in his kit.
Okay, you got to pay close attention to this one. This distinction is super important. Using append is like putting a packed lunchbox into your backpack. The whole lunchbox becomes one single new item. Extend, on the other hand, is like opening that lunchbox and putting the sandwich and the apple in as separate individual items. So remember, append adds one whole thing, extend unpacks and adds many individual things.
Is your list a total mess? Well, the .sort method is here to save the day. It just rearranges all the items in the list, putting them in ascending order right then and there. And notice how it changes the original list directly. This is what we call sorting in place.
Now, the pop method lets you remove an item from a very specific position. You just give it the index of the item you want to get rid of. And what's cool is that it doesn't just remove the item, it also hands it back to you just in case you need to use it for something else.
All right, this is where lists get even more powerful. You can actually put a list inside another list. We call this a nested list. Now, to get to an item that's inside that inner list, you need 2 coordinates, kind of like a map. The first index, 2, gets you to the inner list of marks. Then the second index, 1, gets you the specific mark you want from inside that list.
Okay, I need you to listen up because this is a big one. A word of warning. If you try to copy a list just by saying list 2 equals list 1, you are not actually making a copy. All you're doing is giving the original list a second name or an alias. Both list 1 and list 2 are pointing to the exact same list in your computer's memory. So if you change one, you accidentally change the other, and that can cause some really sneaky, hard-to-find bugs.
So,
how do you make a true copy, a real clone? Well, the solution is actually beautifully simple. You use a full slice. By adding that little colon inside the square brackets at the end, you're telling Python, hey, create a brand new, completely independent list with the same contents. Now you can change list 2 all you want, and list 1 won't be affected at all.
All right, time for a little pop quiz to see what we've learned. We've got a list here with 4 numbers in it. What do you think happens when we .append a new list containing 50 and 60 to it? Go on, think back to that lunchbox analogy we talked about.
And the answer is, the new list 5060 gets plopped in as the 5th element. Remember, append adds just one item, and in this case, that one item just happens to be another list. So we end up with a nested list structure.
Let's try one more. We've got a student's record here stored in a list, and their marks are nested inside it. How would you write the code to pull out just the 5th mark, the number 69? Remember, you're going to need those 2 addresses to find it.
The correct way to do it is record24. Let's break it down. The first index, 2, selects that entire list of marks. Then, from within that list, we need the 5th item. And since we always start counting at 0, the 5th item is at index 4. And boom, that's how you navigate a nested list.
So let's wrap it all up. Leo the list is your ultimate data organizer in Python for 3 main reasons. He's mutable, which means he's flexible and you can change him. He's ordered, so he always keeps your data in sequence. And he's powerful, because he comes equipped with that whole toolkit of methods for pretty much any task you can think of.
And I'm going to leave you with this fantastic thought from Bill Gates. Using powerful tools like lists lets you write smarter, more efficient code, not just more code. It's really about the quality and the effectiveness of your solution, not its size.
Honestly, mastering lists is a huge step forward in your programming journey. They are the absolute foundation for managing complex data, whether it's a simple to-do list or the entire backbone of a huge application. So the only question left is, what will you build with them? Thanks for watching.